Hello. We're going to talk today about something very near and dear to my heart because this is a big part of sixth grade. Now, I know you're in high school, ninth and 10th graders mostly, but ratios are still a very important part. It's something you run into every day, and they also come into play in geometry. So first of all, let's go back down memory lane to sixth grade. And you probably had a cool math teacher who would do ratios with candy. So I'm doing ratios with candy. Sadly, you can't eat these. And I have a special Green Bay Packers assortment of M&Ms. Don't ask me why I picked these colors, but I did. And if I count them all, I'm going to go ahead and line them up and count them all. You can see that I have 4 yellow M&Ms and I have 12 green M&Ms. Well, what I want to do is go ahead and divide these up, but I want to keep the ratio of yellow to green the same. I don't want it to change. So what I'm going to do is first of all look at the yellow and look at the green and see how I could divide those up. And it looks like I could divide it in half. So notice how I'm saying the word divide a lot. In fact, you'll see that ratios, I often say that's a relationship between two values that change in the same way. So if I divide the yellow in half, I should also divide the green in half. Another thing you'll find in your math book is they'll say it is a comparison of two numbers by division, which is why you see a fraction bar sometimes. So I'm dividing it in half, and now I have 2 yellow to 6 green, and 2 yellow to 6 green. But you can see if I put them back together, I still have 4 yellow to 12 green. So right now I have 2 equivalent ratios. Let me see if I can get my little pen. Whoops. And now I have a third ratio, which is 1 yellow to 3 green. So initially when I started this, I started out with 4 yellow to 12 green. I divided that each one in half, and I simplified it to 2 yellow to 6 green. Then I found out, oh, that's still the same as 1 yellow to 3 green. So both values changed in the same way. Now, there are some different types. Well, when we look at ratios in geometry, one of the things we'll be looking at are the Pythagorean triples. So you remember the 3, 4, 5 triangle, and we did this little activity where we applied a scale factor, and we said, oh, okay, what's another 3, 4, 5 type of triangle? Well, we found out that 6, 8, 10 is related to the 3, 4, 5 because it has a scale factor, SF, of 2. Every dimension is times 2. So 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So we'll be working with ratios and scale factors a lot coming up in the next unit, but we're kind of reviewing the ratios right now. Now, when you first started with ratios, there are 3 types, and the first one you worked with the most were part to whole because you were learning about fractions and decimals and percents. You remember elementary, 4th grade, 5th grade. They said, oh, you ate 1 slice of an 8-slice pizza. What fraction of a pizza did you eat? You ate 1/8 of a pizza, 1 eaten out of 8 total. That's a part to whole. Or you broke 1 egg out of 12 eggs. That would be a fraction ratio of 1 out of 12. Percents, if you made a 90% on your quiz, that means you got 90 points out of 100 points total. So you spent a lot of time with these ratios. Some more ratios that you may have spent time with, and you should have in 6th grade, and that you see every day when you're walking around are part-to-part ratios. They're most often in prices. So you can see the gasoline here, the $4.07 per 1 gallon. It's not dollars to dollars, it is money to gasoline. Those are not the same thing. That's why they're called part-to-part. The speed limit here is 45 miles to 1 hour. And then you have the prices in the fruit is $1.99 per 1 pound. Another place you see part-to-part ratios are recipes. So if you're making 1 batch of Kool-Aid, and I know everyone has their own Kool-Aid recipe, it's normally 1 package of Kool-Aid to 1 cup of sugar to 2 quarts of water. And I have heard all sorts of Kool-Aid recipe special ratios out there. But that's normally what the Kool-Aid company says. And you have scale models if you ever put together model airplanes or cars. I know my brothers did. There are different scales of models. You can get a 1 to 48. That's a very popular scale model. And what that means is that the ratio, let's say this wing on this model was, we'll pretend that that wing was some easy number, 10 inches, which it's not, but pretend it's 10 inches. Then the real wing would be 48 times bigger, so it would be 480 inches. So there's a ratio between the real airplane and the model airplane. And last but not least, a ratio we spent a lot of time on this year is slope, where you do the change in height to the change in distance, or the horizontal distance, which is called the rise over the run. There are also whole to part ratios, but we don't really deal with these too much. But one way you could see it is, say I have a class of 28 students, and I could say 16 are girls. So my ratio, a whole to part, would be 28 students to 16 girls. There are 28 total, and 16 of the total are girls. And you could simplify it, 14 students over 8 girls. Now notice how I'm using labels here, ST for students, G for girls. It's very important to use labels. But when you're working in geometry, sometimes you're talking about a side of a shape compared to another side of a shape. So if you're talking about sides, sometimes it's better to just color the corresponding sides on the two shapes. So you could use, and you can color your ratios so that you can just like circle them in color. So that's a pretty good idea. You want to label them one way or another, either with a word if you can, or a color. Now, other ways to write a ratio, and this is keeping the labels, is to, there are 3 different ways to write them. One is using a fraction bar. That doesn't mean that the ratio is a fraction. It just means it's referring to the division. Remember, we talked about how ratios, it's a comparison of 2 numbers by division. So in your example in your notes, it says 70 miles per hour. If I wrote that as a fraction, I would write it as 70 miles to 1 hour. Then I can also use the word to. So I can say 70 miles to 1 hour. And finally, the third way I can write it is using a colon. 70 miles to 1 hour. Then, this is a special type of ratio, actually. You notice how the second part of the ratio has a value of 1. Those special ratios are called unit rates. So, and here you can see, again, prices, speed limits. Okay, so in your example in your notes, it gives you this unit rate, which is 25.2 mpg. Anytime you see the P, that usually means per, and you have the other 2 stand for miles and gallons. So per is like the division bar. And it's not really, that's not a normal way to write a ratio except for unit rates. So how can I write that in a different way? I can say 25.2 miles to 1 gallon of gas, which means when I have 1 gallon of gas, I can go 25.2 miles. Now finally, one quick checklist. How do you know that you are working properly with ratios? The most important thing, and this should be in your notes, is to label your ratios, again, with either word or color. Are the labels in the correct order? So don't use dollars for the gasoline and gasoline for the dollars. Or don't use the hypotenuse label for the leg and the leg for the hypotenuse. Did you simplify the ratios? Remember our first example, we had the ratio of 4 yellow to 12 green, and that actually simplified to 1 yellow to 3 green. The reason it's important to simplify ratios is simplify is simpler. It gets us easier numbers to work with. And I hope you enjoyed our little review on ratios.